In this video, we're going to take a look at how we can prove geometric statements using the two-column proof method. Two-column proofs are just another way to show the logical reasoning of a flowchart, but in a slightly different format. So for this example here, if we're trying to prove that these triangles are congruent, we know that this BD side is reflexive. It is shared between both triangles. And so your flowchart would look something like this, where you name both the givens, you put the reflexive side. So if we keep track of all of those items here, we have an angle, and we have a side. So notice that is our geometric property to show that those triangles are congruent. So let's take a look at how we would convert this flowchart into a two-column proof. So first off, all of the statements inside of these bubbles are going to go in this left-hand side under the statement column. The reasons are all going to be the statements that came underneath the bubbles, basically showing why we can make those statements inside the bubbles. So the first two statements that we can make are just the givens, and that's common practice that whenever you're given information, that will typically be the first statement or two in the two-column proof as well. So we're given in this proof, just like we did in the flowchart, two angles. So then the third statement would be to show our reflexive side. In other words, that those two triangles have that side in common. So once we've established two angles and a non-included side, I then can say that the triangles are congruent using our double AS triangle congruency property. So as you can see, it's a very similar way to show the logic, just instead of a flowchart, in a T-chart where statements are on the left, reasons are on the right. So let's take a look at an example of how we would prove this statement using the two-column method. So in this particular proof, we're given that TR and MN, those two line segments, bisect each other. So the first step, as always, is to write down the given in that first statement and reason box. So in this particular case, we're given that these two line segments bisect each other. So TR bisects MN, and MN does the same thing to TR. Bisect means to split into two equal parts. So TR is getting split into two equal parts, and so is MN. Now we do need to put two tick marks on those because we don't know that those lengths are equal to each other. And those markings are exactly what we put in our statement box. So notice how our given led to the fact that TR is getting split into two equal parts, TP and PR being congruent. Now the reason for that is simply the definition of bisect. We also then can say that NP is congruent to MP for the same reason. And if we're taking inventory of sides and angles, both of those are congruent sides in those two triangles. So we're 2/3 of the way to be able to prove those triangles congruent. If we look at the triangles one more time, we'll see that those triangles intersect at vertex P, creating two congruent vertical angles. So that's my next statement, that those two angles are the same. We do need to use three letters to name those angles. So angle NPT congruent to angle MPR. And our reason is just that vertical angles are congruent. If we're taking an inventory again of what we have, that is a angle. And that angle is in between the two sides, even though it's written as SSA in our two-column proof. So now we're ready to show that those triangles are congruent by our SAS property. If you look back at the picture, just to confirm, we have side, angle, side right there on that triangle, and then side, angle, side on the other. So let's take a look at one more two-column proof. In this one, we're given that angle A is congruent to angle H. So we can mark angle A as the same measure as H. We're also given that angle AMT is congruent to angle HMT. AMT is that angle right there, and HMT is the one right below it. And then if we look at the triangles, they overlap on top of side TM, so we can mark that side the same. So those are the three congruencies that I want to put in my statements and reason boxes. So for this first two statements, we're simply listing those two pairs of congruent angles that we were given. Our third statement was the reflexive property side. And if we're taking inventory again of what we have, that is an angle, another angle, and a side. So let's confirm on the picture whether that side is in between or not. If I look at these angles and sides there, the side is not directly in between the angles. So we can prove the triangle is congruent using our double AS property. And then when you're naming the triangles, just make sure that you're naming them in corresponding order. So here's one way that we could name the triangles congruent. MAT congruent to MHT. So then our last statement is always going to be what we're trying to prove. And when we look at what we're trying to prove, we're trying to show that side AT is congruent to side HT. Well, the good news is that I've proven those triangles congruent. So once I've shown that those two triangles are congruent, I can then say that those corresponding sides or parts are also the same. So in this case, it's side AT congruent to side HT. And the reason is that corresponding parts of congruent triangles are also congruent. So hopefully in this video, you were able to just see that when we do two-column proofs, it's very similar in terms of the logic that we show, just in a slightly different visual method.